Hi, hello, welcome back to our channel. Before the exam, this is just like a revision of the all formulas, and here the topic name is the wave optics. So in this wave optics, you know that Huygens wave theory, based on the Huygens wave theory, he explained successfully what is the reflection, what is the refraction, interference, diffraction and polarization concepts. In that ray optics, we concentrated only on the rectilinear propagation of the light. But in this, Huygens explained that the light is coming like a wave, and he considered that light is forwarding like it is like wave front. So based on the wavefront, he explained that what is reflection, what is the refraction, what are the laws of reflection and what are the laws of refraction and all this. So when we are going through the formulas wise, first thing is the interference. What is the interference? Two light waves are propagating superimpose, and it gives the two constant phase difference and same frequency, and it gives the alternate bright and dark bands, that is called the interference. So two waves means what we are taking here, we can take it. First one is y1 equals to a sin omega t, and second one is y2 equals to a2 cos omega t plus phi. So here a1 cos omega t, and this one how much phase difference is there? Phi. So constant phase difference. Then how to find out the resultant displacement? Y equals to y1 plus y2. Instead of y1 and y2 we are substituting. You are getting that like a big expression in that. But here our main focus is what is the amplitude, what is the resultant amplitude. Here how many amplitudes are there? There are two amplitudes, a1 and a2. Phase difference is the phi. So we can go through the parallelogram law of addition of vectors. Then you can use a equals to under root a1 square plus a2 square plus 2a1 a2 cos phi. Then how to find out the direction? Same, tan theta equals to a2 sin phi by a1 plus a2 cos phi. See, if theta equals to 0 degrees, what you are getting? If theta equals to 0 degrees or theta equals to 2 pi, 4 pi, etc., we are getting a equals to a1 plus a2. Why? Cos 0 equals to 1, it is like a1 square plus a2 square plus 2a1 a2. We can apply the a plus b whole square formula. Anyway, it is repeated in number of chapters. Whenever theta or phase difference equals to 0 degrees, we are getting the maximum amplitude. In this case simply we can do a1 plus a2. Then we can go through the relation between phase difference and path difference. Relation between phase difference and path difference. Look here, phase difference is represented by d phi and path difference is represented by delta x. This is the delta phi is the phase difference, delta x is the path difference. So we should write it delta phi equals to 2 pi by lambda into dx. Then here intensity and amplitude, what is the relation between them? Intensity is directly proportional to amplitude square. So amplitude is directly proportional to under root I. Just now we have written a equals to under root a1 square plus a2 square, that one, no? So instead of a we are writing under root I. This is under root, instead of a1 square I1, instead of a2 square I2. So in terms of intensity we can find out, we can write this expression like this. Then we can go through the both the sides, we are taking the square, means under this under root and that under root both are cancelled. So I equals to I1 plus I2 plus 2 under root I1 I2 cos phi. So from this what we are understanding, when you know the intensity, in terms of intensities and in terms of amplitudes, we can find out the maximum intensity. Maximum intensity means a maximum square. Instead of a maximum we can write it a1 plus a2 whole square. But instead of a1, sometimes they are giving intensities I1 I2, means instead of a1 under root I1 plus under root I2 whole square. Like that, how to find out the minimum? I minimum equals to a minimum square. A minimum is what? When the phase difference is 180 degrees, we are getting the a minimum. So this is the last minute revision. All formulas are covered or not, you should check. It is very useful for you. A1 minus a2 whole square. But instead of a1 we should write it under root I1 minus under root I2 whole square. Suppose they are asking what is the ratio of maximum intensities, means I maximum by I minimum equals to, in terms of amplitude we can use this. or in terms of intensities we can use. Both are same only. Based on the given data we can go through this one. Then condition for maximum intensity. This is called the constructive interference also, and condition that is minimum means destructive interference. See, many people are simply they are remembering in terms of phase difference what is the condition for maximum intensity. No, you should remember in terms of phase difference, as usual path difference. See, condition for maximum intensity, delta phi equals to 2n pi. Here n is the 0, 1, 2, 3 like that you should take it. Like that path difference is the n lambda in terms of wavelength. As usual n equals to 0, 1, 2 like that you should take it. Then condition for minimum. Minimum we have to take it 2n minus 1 into pi. Here also this is the condition for minimum means dark band. In interference we are getting alternate dark and bright bands. This is the phase difference. This is the condition for minimum means that is the dark band. When we will get it, when n value is 0, 1, 2, 3, but the expression is 2n minus 1 into pi. Like that path difference is the 2n minus 1 into lambda by 2. So this is about the interference or superposition of the waves also you can say. Then Young's double slit experiment. This is the Young's double slit experiment. For the Young's double slit experiment we must take the coherent sources, same constant phase difference. Here we are using one source. You take one slit and you make two pinholes are here. These two are illuminated by this source. Now these two are acting as a secondary sources and that light rays are passing like a wave friends. And here you can see this is the S1P and this is the S2P. So S2P minus S1P is called the path difference. See here, bright fringes. We are getting the alternate bright and dark fringes. For bright fringes, what is the condition? S2P minus S1P, path difference. See, this is the S2P and this is the S1P. How much path difference? Just we have to draw on normal delta x, and it should be right d sine theta. Either delta x or d sine theta, both are representing the path difference. For bright band, path difference is the n lambda. Now instead of S2P minus S1P we are writing d sine theta into equals to n lambda, and it should be right d into yn by l. So yn is representing the position of this one, yn by l. So equals to n lambda. See, in terms, when you know this gap also you can able to find out. When you know the t and the distance between these two sources also you can. Otherwise if you know the position of that bright fringe and on that also we have to find out the bright fringe condition is. Then suppose where yn is the position of that one. Now n0 means, suppose n equals to 0 means 0 order fringe, n equals to 1 means first order bright fringe. We are discussing about the bright fringes. Then this is the condition for bright fringe. I equals to, this is the normal formula, I intensity equals to 4 I naught into cos square phi by 2. So when the based on the phi value we are getting the minimum or maximum intensities are constructive and destructive also we are taking. Here phi by 2 equals to, we are taking 0 plus or minus pi plus or minus 2 pi like that. This is for maximum intensity R instead of phi. This is the phi by 2 value. Suppose we want to take in terms of phi means you are getting 0 plus or minus 2 pi plus or minus 4 pi like that you should get it. This is about the Young's double slit experiment. Then we can go through the bright fringe is over dark fringe. Condition for the dark fringe, suppose the dark fringe is there, you know that in interference we are getting the bright and dark bands. But in the case of dark fringe, what is the condition for path difference? S2P minus S1P is a 2n minus 1 into lambda by 2. Instead of S2P minus S1P, we should write it the d sine theta also. Instead of sine theta, we are writing opposite by hypotenuse yn by l, position of this one band, 2n minus 1 into lambda by 2. So we can use anything. Suppose they are asking to find out the yn means we can write this expression. As usual, based on the n also, n values we have to take it for dark fringe. N equals to plus or minus 1, plus or minus 2 are called the order of the dark fringes. If n equals to 1, that is the first order dark fringe. Then n equals to 2, second order dark fringe, but the path difference you see here lambda by 2. For second order 3 lambda by 2, like that we are getting here. So this is about the dark fringe. Now condition for minimum intensity. Minimum means no need of thinking that, simply you can take it intensity equals to 0. But intensity, when we are getting the 0, if 5 by 2 value is the pi by 2, 3 pi by 2, 5 by 2 r, phi equals to plus or minus pi plus or minus 3 pi plus or minus 5 pi also we are getting. So finally phi equals to plus or minus, you can express this is condition for minimum is the 2n minus 1 into pi. This is about the Young's double slit experiment. Then what is the fringe width? The distance between two adjacent bright bands or dark bands, or bright fringes or dark fringes, is called the fringe width. It is represented by lambda. So lambda equals to, it is represented by beta. So beta equals to, what is that expression, lambda L by D. Then beta is, what is the relation between these two? Beta is directly proportional to lambda. Beta equals to directly proportional to lambda. So lambda is more for which color? Red color. So fringe width also more for red color comparing with the violet. Then in certain field of view on the screen, if n fringes are formed when the light of wavelength is lambda 1 and n2 when the light is wavelength is lambda 2. So they have given two wavelengths and how to relate that one. So we can go through the y equals to n lambda L by D constant. So n beta equals to constant, or n lambda equals to constant. So n1 is the number of fringes, beta 1 is the number of fringe width of that one, n2 is the number of fringes for particular light, that one. So you can give the relation between fringes and wavelength separate, you look here. Then lateral displacement of the fringes. In this case what happens? To determine the thickness of the given thin sheet of a transparent material such as glass, mica, for that one what we are doing, we have to do one experiment, same thing only, Young's double slit experiment. You know that these two are coherent sources are there in this path, either this path or this path. We have to introduce one film or like glass or whatever we want to find out the thickness of that particular sheet, we have to place in this. Then what happens? The optical path S1 to P, what happens? S1P minus T plus mu T. This actually we are getting S1P is 2 minus S. This is the, now this is the path difference. This is the path difference. S1P minus T plus optical path mu into T. Finally this is the path difference when we are introducing a small transparent piece here, either glass, mica and all this. Then finally mu minus 1 into T equals to what we are getting, dy by L. You know this gap is called the y. So lateral shift, finally the formula is y equals to L into mu minus 1 into T by D. Then y equals to beta by lambda into mu 1 into T, mu minus 1 into T. So these are the expressions for this. Then the number of fringes shifted means lateral shift by fringe width. So y by beta you can take it. Then it should be right like this also. These are the expressions for this. Then we can go through the, for lateral shift, few more formulas are there. What are those? If the transparent sheet of thickness T and its relative refractive index is the mu r be introduced in one of the beams of that interference, then the lateral shift means you have to remember this formula, y equals to mu r, relative refractive index minus 1 into T into L is the distance between the screen and the coherent sources, D is the distance between the coherent sources. Then the number of fringes shifted equals to n equals to, in terms of relative refractive index, mu r minus 1 into T by lambda. Due to the presence of transparent sheet, the phase difference is how much? Previous we have given that delta phi equals to 2 pi by lambda into delta x. But instead of path difference we are writing mu minus 1 into T. So these are also very, very important. Then interference is over. Next thing is the diffraction. What is the diffraction? Bending of the light around the obstacles is called the diffraction. So based on the, here diffraction also we are getting alternate bright and dark bands, but here intensity is not same for all bright bands, it is in decreasing order. But how many types of diffractions are there? It is classified into two types: Fraunhofer diffraction and Fresnel diffraction. A small thing is there in Fraunhofer and Fresnel. The difference is Fraunhofer is the source and screen is like infinite distance, and here it is the finite distances. For this we require the lens. For this we no need of requiring any lens to observe this one. So these are the few differences. When you can go through the concept, you can read it. Then we can say that, see, whereas interference, all bright bands have the same intensity in interference, but it is different in the case of diffraction. Then condition for minimum intensity and condition for maximum intensity. So in the case of diffraction, these are the expressions, you should write it. A sin theta equals to n lambda, this is the condition for minimum intensity, and A sin theta equals to 2n plus 1 into lambda by 2, this is the condition for what? Maximum intensity. Then we can go through the polarization. In this figure you can observe that what is the polarized light and what is the unpolarized light. When we can go through the unpolarized light, we have to take both arrowheads and dots. Dots are representing particles are vibrating perpendicular to the plane of the paper, and these are like parallel to the plane of the paper. So this is the unpolarized light. It is not restricted in the single direction. If the light is restricted into the single direction, it may be dots or it may be arrowheads. Any one means you can say that is the polarized light. But how it is possible that polarized light? We are using the reflection of the light. From the reflection also we can able to get the polarization. From the double refraction also we can get the polarization. But in the case of polarization, while going through the formulas, you must remember these formulas here. From the reflection, from the Brewster's law, just you have to look this figure once. Brewster's law, unpolarized light falls on the one material. Here we are taking the glass. Then polarized light is completely, this is reflected light is completely polarized, and refracted light is the partially polarized, and this is the angle of polarization. It is represented by IP. It is represented by IP. The next thing is, you must remember these formulas based on the Brewster's law. Mu equals to tan IP. Mu equals to tan theta P. So theta P is the polarized angle. So mu equals to tan theta P by sin R. But R equals to 90 degrees minus theta P means finally mu equals to tan theta P. But you remember these two values. For glass, polarized angle is 57 degrees, and for water you should remember that polarized angle is the 53 degrees. So this is the 57 degrees and this is the 53 degrees. Then effect of polarizer on natural light. See, if unpolarized light of intensity I naught. First of all, what is the polarizer? See, in that calcite crystal we can use as a polarizer. Even sunglasses also we are using, those are acting like a polarizers. When light falls on this, in that all molecules are arranged like this, so only we are getting the half of the intensity. When light falls, maximum intensity is I naught, but here we are receiving half of the intensity. Then amplitude becomes to A naught by root 2. So this is the role of this polarizer. And when we are using this intensity formula, I equals to I naught by 2 cos square theta. A equals to A naught by root 2 cos theta, means depends on the angle we can able to find out the polarization, what is intensity, what is the amplitude in this case. Then we can go through the resolving power. Also few formulas are there. Resolving power, look here. Resolving power equals to 1 by limit of resolution. Suppose some small lines are there, like this one, those are very close to each other, but we have to identify the gap between these two closed lines is called the resolving power. So resolving power is inversely proportional to the wavelength, and resolving power of the microscope, 1 by d equals to 2 mu sin theta by 1.22 into lambda. Then resolving power of telescope is 1 by d theta equals to d by 1.22 into lambda. You must remember these formulas. And in previous video Kinetic theory, I have given mean free path, one formula is wrong, so just please correct it. Sorry for that. That is the lambda, mean free path lambda equals to, that formula is 1 by root 2 pi into n into d square. By mistake I have given n square t, so this is the mean free path. Just previous video, just you have to correct it. So what is the mean free path? The distance between two successive collisions is called the mean free path. Thank you everyone. Please subscribe my channel and share my channel to your friends also. Thank you everyone.